This conference will now be recorded.
All right, this is Math 211, section 2.1. We had a few extra examples that I wanted to do in the video. So we're looking at this example 4. We did every part together except for B. I just kind of gave you the formula since we were short on time. So I want to show you the work that goes behind finding the velocity of the ball when t equals a instead of a specific number. This is standing in general for an arbitrary variable. So this is essentially us doing the limit formula because that's, remember, as the secant lines approach the tangent, that's what the velocity is really represented by, the average velocity turning into instantaneous velocity. So when we go to solve this, we're going to write that the velocity at a generic, essentially A, is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. So I'm using this version of the definition. So then when we plug in for our function, which is right here, this is going to be, remember, don't drop your limit yet. This is limit as h approaches 0 of, let's make a bracket. This will be 40, and we're plugging in a plus h for t. So a plus h minus 16, a plus h squared, close the bracket, minus f of a. So I'm going to have a second bracket, 40 times a minus 16a squared, all over h. Now, sometimes it's helpful if you know you're going to have to square something, you may want to come over to the side, write that out. Just saves you from having to write the whole limit again if you can show your work on the side about the squaring. So this is a squared plus ah plus ah, and you'll see a pattern once you've done these enough. It's always going to be the same. It ends up being a squared plus 2ah plus h squared. So we have that. We're going to go and plug this all back in. So since I've already answered the other questions, I'm just going to kind of write down into this part. So I'm going to distribute that 40. So that's 40a plus 40h. And then I know that this guy right here, remember, is now a squared plus 2ah plus h squared. So I'm going to distribute that negative 16 to that. So that's negative 16a squared minus 32ah minus 16h squared. Distribute it to all three terms. Then I have to distribute my negative here, so that's minus 40a and plus 16a squared all over h. Remember, we cannot remove the limit sign because we still have the problem of if we tried to evaluate this, it's going to make us undefined in the denominator, so we're not allowed to use direct substitution yet. If you notice, there'll be a couple things on the top usually that will cancel out. So we notice that the negative 40a and the 40a cancel out, and the negative 16a squared and the positive 16a squared. That leaves me with the limit as h approaches 0 of 40h minus 32ah minus 16h squared all over h. Everything has an h, so we're able to factor one out of the top and reduce it with everything on the h on the bottom. So that just gives me 40 minus 32a minus 16h. And now we're finally allowed to use direct substitution because we are not dividing by 0 anymore. So this is 40 minus 32a minus 16 times 0 for that h, which means that this is kind of our generic formula now for any a that's on the function that we were given. So any essentially x or t value that goes into that function and has a defined point, we can now find the slope of its tangent line or its velocity at that time by evaluating 40 minus 32 at the actual value of a. So minus the 32a, so you have to plug that in. And we did do C and D in class, so you have that in your notes. Okay, so just to recap, derivatives are, remember, a special name for what we calculate when we do these limits for slopes of tangent lines and instantaneous velocity. These are rates of change, and the derivative of function f at a number a, denoted by f prime of a, is the definition is f prime of a is the limit as h approaches 0 of the f of a plus h minus f of a all over h if the limit exists. We can also write it with the alternative form, which looks more like the secant, f of x minus f of a over x minus a. Remember, that's as the limit as x approaches a. The difference quotient that you learn in Math 136, delta y over delta x, which means change in y over change in x. that's just showing you that as a formula. Remember, is the average rate of change of y with respect to x. That has to do, remember, with the slopes of the secant lines. So if you're talking about instantaneous rate of change, you have to take the limit as the 2 points approach each other, which means the distance between their x values becomes 0. And that is a way of writing that. So that ends up being our instantaneous rate of change, and it's our derivative. So example 5 is just another find the derivative now. It says let's find f prime of a. So we don't know what our value is for a. We're going to be doing this arbitrarily. And this one, I chose one that had a little bit more going on. This is obviously now a rational function, so we have to do a little bit more work to get to the final answer. So let's look at how this would set up. So f prime of a equals the limit. And you could do this either way. You could do, the x approaches a version, or you could do the one where h approaches 0. I'm actually going to do h approaches 0 here. Doesn't matter. It's just that's my personal preference on this one. And remember, the formula is f of a plus h minus f of a all over h. Okay. And then when we plug this in, we're going to get that f prime of a equals the limit as h approaches 0. And then now remember, when we plug this in the first time, we plug in a plus h for all of the x's on both top and bottom. So this will be 2a plus h plus 1 over a plus h plus 2 minus, now we're going to plug in just a, so that would be 2a plus 1 over a plus 2, and then the whole thing is now over h. So make sure you don't forget that piece. Okay, so the problem with this one is there's a lot to clean up. On top, you've got these functions, or these rational functions essentially inside of this. Complex fractions are what we're dealing with. So the only way we can work this out is we're going to have to get a unified front on the top. We're going to have to make this a singular fraction, which means we need a common denominator. So this is a trinomial, and the second one is a binomial, and they're not ever going to match each other. So we have to use each one as part of the common denominator. So for the first fraction, make sure you copy everything down. We're going to be working with, I'm going to go ahead and distribute that 2 on top. So that's a 2a plus 2h plus 1 over the a plus h plus 2. I'm going to times that fraction by a plus 2 on both top and bottom, since that is the other denominator. Minus, and then I have my 2a plus 1, and that's over a plus 2. And this one's going to need the trinomial, so that's a plus h plus 2 and a plus h plus 2. And please don't forget that that is all over h. Okay, so let's work out what's going on top. So we're going to need to distribute or FOIL all of our stuff out. Essentially, we're distributing since it's a trinomial times a binomial. I would not do anything with the denominator pieces. I would just leave them factored, but we do want to work out the tops. So 2a times a is 2a squared. 2a times 2 is 4a. 2h times a is 2ah. 2h times 2 is 4h. 1 times a is a, and 1 times 2 is 2. So there is my first numerator. Excuse me. So sorry. Be careful with the second group. You'll want to leave it, because this is all going to be over our common denominator now. You'll want to leave maybe the second group after in a parentheses first, because you are going to distribute, but then you also have that minus sign that you have to distinguish, and make sure you distribute that through. And then remember, this is all over h. Don't lose our limit. So this is a 2a squared plus a 2ah plus a 4a plus an a plus an h plus a 2. So kind of hard to see all that. Okay, so then we have the limit as h approaches 0. I'm going to go ahead and distribute the negative on the top. So I have 2a squared plus 4a. Actually, we can add some of our like terms together. I have a 5a there because we already had this a that was outside. So that is 5a. We have a plus 2ah plus a 4h, and then plus a 2. Distributing this negative, we get minus 2a squared minus 2AH minus 4A minus another A, so that's actually minus 5A, and then minus H and minus 2. Now that has all been worked out on the top. I'm going to make that a little cleaner. So that was minus 5A when we added the like terms, minus H minus 2. That is still over this denominator. And this is also a fraction as well. It's h over 1. So essentially, you can multiply by the reciprocal, which means this will become times 1 over h, which means h is going to end up in the denominator. So just to make life a little easier, since I'm running out of space, I'm going to go ahead and write that h is actually in a denominator with the two other common denominators, and that's because of multiplying by the reciprocal. So now we're looking for cancellations on top. So we have our 2a squareds are going to cancel out, our 5a's are going to cancel out, and our positive 2's. And then I think that is, nope, we have a 2ah and a negative 2ah. And so all I have left on top is a 4h minus an h. So that gives me the limit as h approaches 0 of 3h over h times a plus 2 times a plus h plus, or a plus h plus 2. And then h is going to cancel out on top and bottom since we have a monomial that they have a common factor. And now that that h is gone from the denominator, we can plug in our 0. So this is 3 over a plus 2. And then you get another a plus 2 because the h goes to 0. So that's going to be a plus 2 squared. So that is the derivative of that function at any arbitrary value a. Now, the last two examples in this section, we're just going to be looking at how to use information that we've been given to find other pieces of information. And this first one says, find an equation of a tangent line to the graph y equals g of x at x equals 5 if we know that g of 5 equals negative 3. That means we actually have an ordered pair. So anytime you see g, not g prime, but g of 5 equals a number, that means that the ordered pair 5, negative 3 is on the original function. It's a point. We could plug, if we had the function in front of us, we could plug in 5 and the answer would be negative 3. And then they also told us that g prime of 5 equals 4. Remember, anytime you're taking the derivative at a specific value, that is then the slope of the tangent line at x equals 5. So we actually have our ordered pair and we have our slope. So we're just writing the equation of that tangent line. So it's point slope. So y minus negative 3 equals 4, sorry. 4 is the slope. And then x minus 5. So that's going to be y plus 3 equals 4x minus 20. Add over the 3. Or excuse me, subtract the 3. It's way too late to be making a video. So y equals 4x minus 23. That is my equation of my tangent line, and that is exactly what we were asked to find. All right, so the last one on 2.1 says if an equation of a tangent line to the curve y equals f of x at a point where a equals 2 is y equals 4x minus 5. Find f of 2 and f prime of 2. Now, here's the good thing. If you already have the equation of the tangent line, you already know the slope at that point. So this is the slope of the tangent at the a equals 2. Now, that means it's this guy, because remember, f prime at 2 is the slope of the tangent. So f prime of 2, just from the equation, is going to be 4. Okay, so that's the first part. The second part asks us to find f of 2. Now, not only do we not have our original function, but we know that this is the slope. This is not, f of 2. It's not just any specific value here, but this is the nice thing about tangents. Remember, whatever my function f of x is, the tangent is actually touching at that singular point. So f of 2 is on both of those lines or curves at the same time because it's the tangent point. So all we have to do is plug it into the tangent line equation, and that'll still tell us what that point was on the original function. So f of 2 is 3. All right, so that's the end of the section 2.1 video.